Hello and welcome to my presentation on our ICCV paper called Foreground-Background Separation for Concept Distillation from Generative Image Foundation Models. My name is Mischa Dombrowski. I'm from the Friedrich-Alexander University in Erlangen-Nuremberg, and I've been working together with my colleagues from Imperial College London and my supervisor Bernhard Kainz. Our main goal is to separate foreground from background without any pixel-based labels. We assume that we have a dataset available where all foreground objects can be described using the same natural language term. The motivation is that after separation, the foreground or the background dataset can be leveraged for further downstream applications. This means that we take a full dataset of bird images, for example, and fine-tune Stable Diffusion with multiple tasks in mind, including background synthesis, object segmentation, object removal, and image synthesis. Our proposed approach leverages pre-trained text-to-image foundation models. Specifically, we use Stable Diffusion and a generic input query describing the image, such as a photo of a bird, for zero-shot segmentation. The zero-shot segmentation itself works by extracting the attention probabilities corresponding to the token describing the object from the hidden layers of the diffusion model. Here you can see some qualitative results on birds, cars, dogs, and humans. However, you can see it also on a concept level with arms and legs. However, there are still two main problems remaining. Firstly, the attention layers only produce low resolution maps where the object usually appears larger than it actually is. Secondly, the masks are only producing a continuous prediction. Therefore, we would require setting a hyperparameter for foreground and background pixels. To resolve this problem, we propose a hyperparameter-free approach by using sample-wise bimodal Gaussian mixture models. This means that we assume that every pixel of the image either belongs to the foreground or the background. This results in binarized masks, which is part one of our proposed iterative refinement pipeline. In the next step, we fine-tune the diffusion model on two tasks simultaneously. The first task is full image synthesis with the prompt a photo of a bird. The second task is where we take a randomly selected rectangle using the binarized mask from the previous step from the background and paint it with the prompt a photo of a background using the ground truth background. In the final step, we use the binarized mask again, but this time to select the foreground region. We paint the foreground with the prompt a photo of a background to remove the object from the image. Then we subtract the full background image from the input image to get a refined mask. The foreground separation is evaluated by training a simple unit on the generated masks. As you can see, the boundaries are no longer too large and the model has learned to separate the described object from the foreground. Quantitatively, we compare our approach to previous state-of-the-art methods in terms of accuracy, IOU and mean IOU, and see that our method beats all the other methods and closes the gap towards fully supervised training of the unit, where the unit is trained on the ground truth segmentation masks that are available for the dataset. More importantly, since we have a generative model, we can generate a purely synthetic dataset, and we input the synthetic dataset back into our model to generate a purely synthetic mask dataset. And then we train on this augmented dataset and show that this improves the performance even further. Additionally, we compare the generative results against other methods and see that we also beat them in terms of FID on all the tested datasets. Finally, we show that the model has learned the concept of foreground and background. Using the prompt a photo of a background, we are now able to generate a fully synthetic background dataset, as you can see here. Furthermore, by leveraging classifier-free guidance, we can generate birds and background images. We fix the noise seed, change the classifier-free guidance scale, and combine all the generated images to a video. This way, we visualize how the model has learned to interpolate between the two concepts, background and foreground. Thank you very much for your interest. If you have any questions, feel free to contact me or come visit me directly during my poster session on Wednesday at 10:30 a.m.